This question tells us that an infrared heater produces radiation with a wavelength of 1 millimeter. Its output is 1500 joules per second, or 1500 watts. We are asked how many joules are in one photon. To find the number of joules in one photon, let's focus on the 1 millimeter. Now, 1 millimeter is a wavelength. And remember that wavelength must be in meters. So if we have 1 millimeter, we can change this using our SI prefixes. Recall that milli is E-3, and so we will use 1E-3 meters for our wavelength. Now, to actually find the energy, we have two options. We can use E equals H times frequency, or E equals H times C divided by lambda. Now, since we know the wavelength, option 2 would be more favorable for us because option 1 would take more steps. We know that the wavelength is 1 times 10 to the negative third. H is Planck's constant. That is 6.626 times 10 to the negative 34. And C is the speed of light, 2.998 E8. All we need to do is place the numbers into their correct positions. Now we can use a calculator to find the actual energy. We'll end up with 1.99 E-22. The answer will be in joules. Now, question B asks, how many photons are being emitted each second? So we are emitting 1500 joules every second. This is going to be our whole. However, we can say that our parts that we are emitting are these photons that we found out about in part A. Those parts have 1.99 times 10 to the negative 22 joules. So to find how many parts can fit in a whole, we take the whole divided by the parts. So we'll take 1500 joules and divide by 1.99 E minus 22. We'll end up with 7.55 E24. This is the number of parts in the whole, so this is our number of photons. Notice it's about 1 mole every second. It's slightly bigger because it's E24 rather than E23. We could say this is about 10 times a mole. If you did want to find the number of moles of photons, all you would need to do is take the 7.55 times 10 to the 24 and divide by Avogadro's number. This will give us 12.5 moles of photons. So slightly higher than what we predicted a moment ago.